Welcome back, everyone. So today we're going to be doing a deep dive into the world of recommendation systems.
Okay.
You know, the algorithms that power, apps like TikTok, Instagram, and YouTube.
Right.
And we've got some pretty cool source material to work with today.
Right.
Research from the engineers at ByteDance,
Okay.
the company behind TikTok.
Mm-hmm.
Now, I don't know about you, but I find their recommendations eerily accurate sometimes.
Yeah.
It's like they know me better than I know myself.
Right. It is amazing how good it is.
It really is.
TikTok's recommendations are incredibly sophisticated, actually.
Yeah.
What's really fascinating is their new system, Monolith,
Okay.
which is designed to generate those recommendations in real time.
Yeah.
Every scroll, every tap, it's all being fed into the system.
So they're analyzing my behavior as I'm using the app?
Yeah.
That's a bit mind-blowing.
Yeah. But it's super interesting how they do it. I mean, what really is interesting to me is this concept of a collisionless embedding table.
Collisionless embedding table.
Yeah, have you heard of that?
I've seen that in the research, but can you break that down for us? It sounds pretty technical.
Yeah. No, it is, but it's also a key innovation.
Okay.
Imagine a library with billions of books.
Okay.
And just as many library card holders.
Okay, so a very large library.
Very large.
Yeah.
To make sure every book and every borrower can be found quickly.
Right.
Each one needs a unique identifier.
Yeah.
In the card catalog, right?
Okay.
So that's essentially what the collisionless embedding table does.
I see.
It ensures that every user and every video on TikTok has a unique representation within the system.
So it's like a
massive digital filing system.
Yeah.
Where everything has its own specific spot.
That's a great way to put it.
That makes sense, but why is that so important for recommendations?
Well, it all comes down to accuracy.
Okay. If you have two users with similar interests.
Right.
But their data gets mixed up because they share an identifier.
Okay.
The recommendations will be less precise.
I see.
The collisionless table prevents this.
Okay.
By making sure every piece of data has its own distinct address.
So it's about maximizing the model's ability to differentiate between users and videos.
Right.
Even when they have overlapping characteristics.
Right. Even when they have similar interests or whatever.
Okay. But with billions of users and videos, doesn't this require...
You're thinking about the memory.
Yeah. Doesn't it require an insane amount of memory?
Yeah, memory efficiency is a major concern.
Yeah.
But that's where Monolith gets really clever.
Okay.
It employs a couple of strategies to keep the table manageable.
Right.
First, it filters out IDs that occur infrequently.
What do you mean?
Well, think about it.
Okay.
If a user rarely opens TikTok or a video hardly gets any views, their data doesn't contribute that much to the overall training process.
So it's like spring cleaning
exactly
for their data.
Yeah.
Getting rid of the clutter.
Precisely.
Like so.
And the second strategy is to set an expiration date for inactive IDs.
So if someone's not using TikTok...
If a user hasn't interacted with the app in a while...
Yeah.
Their ID and data is eventually removed.
I see.
Keeping the table focused on active user behavior.
Okay, so it helps them keep the table relevant to what's happening right now.
To what's happening now.
That's smart.
It is.
Kind of like a self-cleaning oven.
Yeah, like a self-cleaning oven.
But even with those optimizations, we're still talking about a huge amount of data being processed in real time.
Yep.
How does Monolith actually learn and adapt as users interact with the app?
So that's where online training comes in.
Online training?
Yeah.
What is that?
So traditional recommendation systems
are
trained in batches on historical data. But Monolith takes it a step further.
How so?
By continuously updating the model with real-time user actions.
You mean like as I'm scrolling?
Yeah, so every scroll, tap, and is being used to fine-tune the recommendations on the fly.
So it's like the system is having a conversation with each user in real time.
Exactly.
That's pretty cool.
And to handle the volume of data, they use these super efficient systems called flank streaming jobs and Kafka queues.
So what are those? Like, what do they do?
Yeah, you can think of them as like high-speed delivery pipelines for information. Every time you interact with TikTok, your action is instantly paired with relevant features. And fed into the model for continuous learning.
So it's constantly learning.
Constantly learning, constantly updating.
Okay, this is getting really interesting.
Yeah.
But what about delayed feedback?
Delayed feedback.
Yeah, sometimes I see a product on TikTok.
Right.
And don't buy it until like days later.
Oh, yeah, sure.
Does the system account for those kinds of delays?
It does. How do you think it does that?
I don't know. That's why I'm asking.
Oh, right, of course.
Yeah.
Well, it uses something called on-disk key value storage.
Okay.
Basically, it's a massive database that stores information about past interactions.
Oh, right.
For a longer period of time.
Okay.
So even if you don't buy that gadget right away,
right,
the system remembers that you showed interest in it.
Okay.
And this long-term memory is factored into future recommendations.
So even my procrastination is being analyzed.
Yeah. Even your procrastination.
That's both impressive and a little scary.
Yeah. I mean, it is remarkable how much data is being captured and analyzed.
Yeah.
But it's important to remember that this system is designed to make your experience on TikTok as engaging as possible.
Right.
It's about understanding your preferences.
Okay.
And presenting you with content you're likely to enjoy.
That makes sense.
Yeah.
So we've got this massive, constantly updating model that's learning from every user action. Right. But how do those real-time updates?
So you're thinking, how does it actually get to the servers?
Yeah, how do they actually get to the servers that are showing me my personalized feed?
Right.
Are my recommendations based on data that's like seconds old?
That's where the magic of parameter synchronization comes in.
Parameter synchronization.
Yeah.
Okay.
Instead of sending the entire updated model every time, Monolith uses a clever technique called incremental on-the-fly parameter synchronization.
So it's not like downloading a whole new app every time there's an update?
Yeah, no, it's not like that.
Okay.
They only send the changes.
Okay.
The parameters that have been updated based on recent user actions.
All right.
And to optimize this further, they distinguish between sparse parameters, which change frequently, and dense parameters, which evolve more slowly.
Okay, can you give us an example of what those different parameters might represent?
Sparse parameters might be related to your specific actions.
Okay.
Like liking a particular video or following a certain creator.
Okay.
These change rapidly as you interact with the app.
Right. Right.
Dense parameters, on the other hand, might represent broader trends or patterns in user behavior.
Got it.
Like the overall popularity of certain video categories.
I see.
These change more gradually.
Okay.
So they're fine-tuning the recommendations at different speeds depending on the type of data.
So they're fine-tuning the recommendations at different speeds.
At different speeds.
Depending on the type of data.
Yeah.
That's pretty cool.
And this allows them to keep the recommendations incredibly fresh and relevant.
Okay.
Without overwhelming the system with constant updates.
That makes a lot of sense.
Right.
This is all incredibly impressive. But I'm curious about the practical side of things.
Okay.
If the system is constantly updating, what happens if a server crashes?
That's a crucial question.
Yeah.
And it highlights one of the most interesting aspects of Monolith's design.
What's that?
Its approach to fault tolerance.
Okay.
To prevent data loss, they take daily snapshots of the training servers.
Okay, so daily snapshots.
Yeah.
But what's surprising is that despite the infrequent snapshots, the impact of server failures is minimal.
It's pretty minimal.
Wait, so backing up the system once a day is enough?
Pretty much.
To maintain performance?
Yeah.
Even with all those real-time updates happening?
It turns out it is.
Why is that?
Well, it comes down to a few things.
Okay.
First, the system is distributed.
Okay.
Meaning the data is spread across multiple servers.
So if one server goes down...
Yeah, if one goes down.
It only affects a small portion of the overall data.
It only affects a small portion.
So it's like having multiple backups.
Yeah, exactly.
Okay, that makes sense.
The second factor is the slow update rate.
Right.
Of those dense parameters we discussed earlier.
Yeah, those are the ones that represent broader trends, right?
Yeah, broader trends.
Yeah.
So even if they lose a day's worth of updates on those dense parameters, it's not a major setback.
So they're essentially prioritizing real-time performance, even if it means accepting a slightly higher risk of temporary data loss.
That's a good way to put it.
And it seems like the gamble paid off.
It seems like it, yeah.
Why is that? Like, why is the risk so low?
Well, they've calculated that the actual risk of significant data loss is extremely low.
Okay.
It really comes down to the architecture of the system.
So they've managed to create a system that's both incredibly fast and surprisingly robust.
Right.
This is all really fascinating.
I think so too.
I'm eager to dig into the results of their experiments to see how this actually plays out in practice.
I think you'll find the findings are quite impressive.
Okay, well, before we get to that, let's take a quick break.
Sounds good. All right, so let's dive into those experiments.
Okay.
One of the key questions they wanted to answer was whether this collisionless embedding table actually made a difference in recommendation accuracy.
So they wanted to test it out.
Yeah, they tested it on a couple of data sets.
Okay.
One was MovieLens.
MovieLens, okay.
Which is a classic benchmark for recommendation systems.
Right.
The other was their own internal data set from a real recommendation model.
So they wanted to see if it worked in both a controlled environment and a real-world scenario.
Yeah, exactly.
That makes sense. And what did they find?
Yeah. What did they find?
Well, the results were pretty clear.
Okay.
In both cases. The models using the collisionless embedding table outperformed the models that allowed collisions.
So it actually made a difference. It made a difference.
Wow.
And this held true across different metrics, including AUC.
And AUC is?
Which measures the model's ability to rank recommendations.
Got it.
So avoiding those collisions really does make a difference.
Okay.
When it comes to generating accurate recommendations.
That's good to know.
What about the online training aspect?
Yeah. Did they see any benefits from that real-time learning?
They did. They ran a simulated online training experiment.
Okay.
Using a data set from the Criteo Display Ads Challenge.
Okay.
This allowed them to compare models trained in batches to models that received real-time updates.
So like the Monolith system?
Yeah, okay. They synced the parameters at different intervals to see how that affected performance.
So they were testing how frequently the model needed to be updated to see the best results.
Exactly.
Okay, cool. What did they find?
The models with online training consistently performed better.
So the real-time.
The real-time was that. And the more frequent the updates, the better the performance.
Oh, wow.
So the shorter the synchronization interval, the higher the AUC.
So it seems like the sooner the model learns about your latest actions, the better it can tailor the recommendations.
Exactly.
That makes sense intuitively.
Yeah.
But did they test this in a real-world setting?
Yes, they did.
Okay.
I mean, a simulation is one thing.
Right.
But how did it actually perform with real TikTok users?
Right.
So they ran a live A/B test on one of their actual ads models, comparing online training to batch training.
So real users seeing ads?
Yeah, real users seeing ads.
Okay.
And the results were pretty impressive.
Okay.
The online training model showed a significant improvement in AUC, averaging over 15% higher.
Wow.
Than the batch training model.
15% higher? That's a huge difference.
It's a big difference.
That really highlights the power of real-time learning.
Real-time learning makes a big difference.
Yeah. Hey, I have one more question about the practical side of things.
Okay.
We talked earlier about how they take daily snapshots of the training servers to protect against data loss in case of a crash.
Right.
But how much data are they actually risking?
You mean with those daily backups?
Yeah, like with the daily backups.
That's a great question.
Yeah.
Initially, they thought they would need much more frequent snapshots.
Okay.
Perhaps hourly?
Hourly. Wow.
To ensure they didn't lose too much data.
Okay.
But what they found was really surprising.
Okay.
Even with daily snapshots.
Yeah.
The impact on model quality was negligible.
So backing up once a day is enough.
Pretty much, yeah.
They're essentially trading a tiny bit
right.
of potential data loss for a significant gain in real-time performance.
Yeah, and it seems like the gamble paid off.
It seems like it did. Why is that?
Well, it comes down to a few things.
Okay.
First, the system is distributed.
Okay.
Meaning the data is spread across multiple servers.
Okay.
If one server goes down,
right.
it only affects a small portion of the overall data.
So it's like having multiple backups.
Exactly like having multiple backups.
Okay.
The second factor is the slow update rate.
Yeah.
Of those dense parameters we discussed earlier.
Right. The ones that represent broader trends.
Broader trends, exactly.
Yeah.
So even if they lose a day's worth of updates on those dense parameters, it's not a major setback.
It seems like they've really struck a balance between speed, efficiency,
right,
and robustness.
Yeah, it's a fascinating example.
It is.
of how engineers are pushing the boundaries of what's possible with recommendation systems.
Absolutely. And it's worth noting that this finding challenges some traditional assumptions about system design.
Yeah, like in the past, there's been a strong emphasis on very frequent backups.
Yeah, to ensure maximum reliability.
Right. Maximum reliability.
It's like they're saying, hey, we can afford to be a little bit more relaxed about the backups.
Right.
Because the impact is minimal.
Minimal.
And the benefits of real-time learning.
The benefits are huge.
Are so significant.
They're huge.
And this allows them to free up valuable computing resources for other tasks.
Exactly.
It's a really smart approach.
It is a really smart approach.
So to sum up, they've created a system that's incredibly fast. Constantly learning. And surprisingly resilient.
Surprisingly resilient.
And all of this is designed to provide users with the most timely and relevant recommendations possible.
I agree.
What are the bigger implications?
The bigger implications.
Yeah, like how might this real-time personalization shape our online experiences in the future?
That's a really interesting question.
Yeah.
And one that deserves careful consideration. Yeah. On the one hand, these systems have the potential to make our online interactions more enjoyable and efficient.
Okay.
Imagine a world where you effortlessly discover new content, products, and connections that are perfectly tailored to your interests.
It's almost like having a personal concierge for the digital world.
Exactly.
But on the other hand, we need to be aware of the potential downsides.
Of course.
As these systems become more sophisticated, we need to make sure they're being used responsibly.
Responsibly.
Yeah. We don't want to end up in a world where algorithms control our choices. And limit our exposure to diverse perspectives.
That's a crucial point.
Yeah. It's important to maintain agency. And awareness. In the face of these powerful technologies. We need to make sure we're using them. Not being used by them.
Exactly. And I think it's important to remember that these systems are ultimately tools. They can be used for good or for ill. It's up to us as users and as a society to shape how they're developed and deployed.
I agree.
We need to be having conversations about the ethical implications of these technologies and making sure they're aligned with our values.
Well said. So to wrap up this deep dive into the world of real-time recommendations, I think the key takeaway is that we're on the cusp of a major shift.
I agree.
In how these systems work.
Definitely.
Indeed, Monolith's approach with its collisionless embedding tables, real-time training, and innovative approach to fault tolerance is a glimpse into the future of recommendations.
It is.
A future where our digital experiences become even more personalized, responsive, and intertwined with our real-time behaviors.
And as we step into this future, it's crucial that we do so with awareness, critical thinking, and a commitment to ensuring that these technologies serve us, not the other way around.
Couldn't agree more.
All right.
So as always, deep divers, we encourage you to keep exploring.
Keep exploring.
Keep questioning.
And keep shaping the future of tech.
Shaping the future.
A huge thanks to our expert for this incredible journey.
Oh, it's my pleasure.
Into the mind of a recommendation system.
Absolutely.
And thanks to you.
Yes.
Our listeners.
You're joining us on this deep dive.
It's been great.
Until next time, keep exploring.
Keep exploring.
Keep questioning.
We're questioning.
And keep learning. So it seems like we're entering this new era.
Yeah.
Where our online interactions are becoming increasingly personalized and responsive to our every move.
To our every move. It's true.
It's exciting and a little bit unsettling.
A little unsettling. I agree.
At the same time.
At the same time.
Right.
Yeah, I agree. The pace of innovation in this field is incredible.
Yeah.
What's fascinating to me is how Monolith's design is pushing the boundaries of what we thought was possible.
Yeah.
They're achieving a level of real-time performance that was unimaginable just a few years ago.
It's like they've cracked the code for building recommendation systems that can keep up with our ever-changing preferences. And the implications for how we interact with technology are huge.
Absolutely.
Yeah.
One thing that really struck me about this research was their willingness to challenge conventional wisdom.
Yeah. Like what?
Well, for example, the idea that you need constant backups to ensure reliability.
Okay.
Monolith shows that in some cases, you can afford to be a bit more flexible.
Yeah.
And that opens up new possibilities for system design.
It's a great reminder that sometimes the biggest breakthroughs come from questioning assumptions and trying new things.
Exactly.
But as we move into this future of hyper-personalized experiences, what are some things?
Yeah, that's a good question.
We should be thinking about.
Well, I think it's crucial to be aware of the potential impact on individual autonomy.
Okay.
As these systems become more sophisticated, we need to make sure they're empowering users, not limiting their choices or narrowing their perspectives.
That's a really important point.
It is.
We don't want to end up in a world where algorithms are dictating our tastes and preferences.
Tastes and preferences.
We need to maintain a sense of agency and control over our online experiences.
I agree, and I think transparency is key.
Transparency.
Users should have a clear understanding of how these systems work and how their data is being used. They should be able to adjust their privacy settings. And control the level of personalization they receive.
It's about finding the right balance between convenience and control.
Convenience and control, that's right.
We want these systems to enhance our lives, not take over.
Not take over.
Right.
I completely agree.
Yeah.
And I think it's an ongoing conversation as technology evolves.
Yeah.
We need to keep revisiting these questions and making sure our values are reflected in the way these systems are designed and deployed.
It's like we're navigating uncharted territory.
We are. It's a new world.
Yeah.
But that's what makes it so fascinating.
It is fascinating.
And it's why it's so important to have these conversations and explore these ideas.
I couldn't have said it better myself.
Okay.
This deep dive into Monolith has been a real eye-opener.
Yeah.
It's shown us what's possible with real-time recommendation systems.
And raised some important questions.
It has.
About the future of online personalization.
It really has.
Absolutely a huge thanks to you.
Oh, you're welcome.
For sharing your expertise with us.
It's been my pleasure.
It's been a truly enlightening conversation.
Yeah, I think so too.
And to all our listeners out there.
Yeah.
Thanks for joining us on this deep dive.
Thanks for listening, everyone.
We hope it sparked your curiosity.
Yeah.
And given you some food for thought.
Some food for thought.
Until next time, keep exploring.
Keep exploring.
Keep questioning.
Keep questioning.
And keep learning.